Generally, splices are not permitted within a disconnect enclosure. The primary function of a disconnect is to provide a point to energize a circuit for safety during maintenance or repair. Introducing splices within the enclosure can compromise this function and create potential hazards. Electrical codes, such as the National Electrical Code, often have specific requirements for enclosures and the equipment they contain. Disconnects are designed to house only the components necessary for disconnecting the circuit, such as the switch mechanism and terminals for connecting conductors. Adding splices introduces additional connections, increasing the risk of loose connections, insulation failures, and overheating. Moreover, the enclosure's internal space is typically calculated based on the size and number of conductors and components it is designed to house. Introducing splices can overcrowd the enclosure, making it difficult to work safely and potentially hindering the disconnect's proper operation. While some exceptions may exist under very specific circumstances, such as factory-installed splices or those explicitly permitted by the equipment manufacturer, the general rule is to avoid splices within a disconnect enclosure. If splices are necessary, they should be made in a separate junction box or enclosure designed for that purpose. These junction boxes should be properly sized and installed according to electrical code requirements. The conductors should then be run from the junction box to the disconnect enclosure. Consider an example where you have a motor circuit that requires a disconnect for maintenance purposes. Instead of splicing the motor conductors within the disconnect enclosure to extend their length, you should install a separate junction box near the disconnect. Make the splices within the junction box, ensuring they are properly insulated and secured. Then run continuous conductors from the junction box to the disconnect terminals and from the disconnect terminals to the motor. Firstly, always consult the specific electrical codes and regulations applicable in your jurisdiction. These codes may have specific requirements or exceptions related to splices in enclosures. Secondly, refer to the manufacturer's instructions for the disconnect equipment. The manufacturer may have specific guidelines or warnings regarding the installation and use of the equipment, including whether splices are permitted. Thirdly, ensure that any splices are made using approved connectors and methods. The connectors should be suitable for the type and size of conductors being spliced, and the splices should be properly insulated and secured to prevent loose connections or insulation failures. Fourthly, properly size the junction box or enclosure used for making splices. The enclosure should be large enough to accommodate the conductors, connectors, and any necessary slack in the conductors. It should also provide adequate working space for making the splices safely. Fifthly, ensure that the junction box or enclosure is properly grounded. Grounding helps to protect against electrical shock and provides a path for fault current to flow back to the source. Sixthly, label the junction box or enclosure to indicate its purpose. This helps to identify the enclosure and prevent unauthorized access or modifications. Seventhly, inspect the splices and connections regularly to ensure they are in good condition. Look for signs of loose connections, insulation damage, or overheating. If any problems are found, repair them promptly to prevent electrical hazards. Eighthly, consider using terminal blocks or other approved methods for making connections within the disconnect enclosure. Terminal blocks provide a secure and organized way to connect conductors, and they can help to reduce the risk of loose connections. Ninthly, avoid overcrowding the disconnect enclosure with conductors or components. Overcrowding can make it difficult to work safely and can hinder the proper operation of the disconnect. Tenthly, if you are unsure about any aspect of the installation, consult a qualified electrician. A qualified electrician can provide expert advice and ensure that the installation meets all applicable codes and regulations. The general principle is that a disconnect enclosure's primary purpose is to house the disconnect switch and provide a safe means of isolating the electrical circuit. Introducing splices complicates this and can lead to safety and code compliance issues. Therefore, it's best practice to keep disconnect enclosures free of splices unless specifically permitted by code and the manufacturer's instructions. In any electrical installation, safety is paramount. When dealing with disconnects and splices, adhere to established codes, best practices, and manufacturer guidelines to ensure a safe and reliable electrical system. If you are not comfortable working with electricity, always consult a qualified electrician. Always to energize the circuit before working on any electrical equipment. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Inspect all tools and equipment before use to ensure they are in good working condition. Never work on electrical equipment in wet or damp conditions. Be aware of the potential hazards associated with electricity, such as electrical shock and arc flash. Follow all safety procedures and guidelines to minimize the risk of injury. Double-check all connections and terminations to ensure they are secure and properly insulated. Use a multimeter to verify that the circuit is de-energized before working on it. Keep the work area clean and free of clutter. Use proper lifting techniques to avoid back injuries. Be aware of your surroundings and watch out for potential hazards. Take breaks when needed to avoid fatigue. If you are unsure about any aspect of the work, ask for help from a qualified electrician. Remember, electricity can be dangerous, so always take precautions to protect yourself and others. When dealing with electrical installations, it is essential to have a thorough understanding of the relevant codes and regulations. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. Other countries and regions may have their own electrical codes, so it is important to be familiar with the specific requirements in your area. Electrical codes are designed to ensure the safety of people and property. They are based on years of experience and research, and they are regularly updated to reflect new technologies and best practices. Compliance with electrical codes is not only a legal requirement, but it is also a moral obligation to protect the safety of others. When planning an electrical installation, it is important to consult the electrical code and ensure that all work is performed in accordance with its requirements. This includes selecting the appropriate wiring methods, sizing conductors and overcurrent protection devices, and properly grounding the system. It is also important to obtain any necessary permits and inspections from the local authorities. The electrical inspections are conducted by qualified inspectors to verify that the installation meets the requirements of the electrical code. If any violations are found, they must be corrected before the installation can be approved. Working with electricity can be dangerous, so it is important to have the necessary training and experience. Qualified electricians have completed extensive training programs and have demonstrated their knowledge and skills through examinations and certifications. They are familiar with the electrical code and have the experience to perform electrical work safely and effectively. If you are not a qualified electrician, it is best to leave electrical work to the professionals. Attempting to perform electrical work without the necessary training and experience can be dangerous and can result in serious injury or property damage. When hiring an electrician, it is important to check their qualifications and references. Make sure they are licensed and insured, and ask for proof of their training and experience. It is also a good idea to get multiple quotes before hiring an electrician. This will allow you to compare prices and services and choose the electrician who is best suited for your needs. Once you have hired an electrician, be sure to communicate your needs clearly and provide them with all the necessary information about the project. This will help them to perform the work efficiently and effectively. During the installation, be sure to follow all safety procedures and guidelines. Keep the work area clear and free of clutter, and wear appropriate personal protective equipment. If you have any questions or concerns, do not hesitate to ask the electrician. They will be happy to explain the work they are doing and answer any questions you may have. After the installation is complete, be sure to inspect the work carefully to ensure that it meets your expectations and the requirements of the electrical code. If you find any problems, contact the electrician immediately and have them corrected. By following these guidelines, you can ensure that your electrical installation is safe, reliable, and compliant with all applicable codes and regulations. Remember, electricity is a powerful force, so it is important to treat it with respect and take all necessary precautions to protect yourself and others.